Let's use the law of cosines to solve some triangles that we couldn't solve before. So here's an example that is side angle side, and this is one of those examples where the law of sines doesn't actually help. So let's use the law of cosines. You can see all three versions of the law of cosines have an angle in them, and all three sides. Well, one of the sides that we don't know, one of the sides is one of the things we don't know, and so in order for the law of cosines to have only one unknown, it's guaranteed to have an unknown side because of the side length A. So we need to choose the version of the law of cosines that has an angle that we already know. And so we need to choose this first version of the law of cosines because that's the only angle that we know at this point. All right, so we're going to use a squared equals b squared plus c squared minus 2bc times cosine of a. Now we can put in everything we know. So a squared equals b is 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 35 degrees. Okay, so a squared is 100 plus 144 minus 2 times 120, that's 240 times cosine of 35 degrees. 35 degrees, we're going to have to use a calculator for that, for sure. 35 degrees is not one of the nice angles. So 100 plus 144 minus 240 times cosine of 35 is 47.4. And then we'll take the square root of that, and we get 6.885. And sorry, this isn't a squared, this is a. All right, so now we know what a is, 6.885. I guess the only thing left to do is find one of the two angles, B or C, because then we can just do some subtraction to find the remaining angle. Let's find C. You could do either one. The situation is symmetric, so let's find C. And that's actually not the only choice we have to make. Now, at this point, we do know an angle-side pair. So if we wanted to, we could use the law of cosines, or I'm sorry, the law of sines, but also we could use the law of cosines. So which should we use? Well, we're going to be looking for an angle. And if you remember back to using the law of sines, it's when you tried to find an angle that you ended up with multiple possibilities and all sorts of trickiness that could happen. So that's what's in store for us if we use the law of sines. But on the other hand, we started out knowing two sides and an angle between them. So these measurements that we started with, these three here, these should lock down the triangle completely. There shouldn't be multiple possibilities. So if we use the law of sines, it might produce multiple possibilities, even though there should be only one. We're going to have to do some careful thinking to choose the correct of the two possibilities that the law of sines gives us. So, that's doable, but sounds tricky. On the other hand, if we use the law of cosines, it will produce only one angle. One advantage we saw of the law of cosines is because the restricted domain of cosine is from 0 to 180 degrees, finding an angle, using the law of cosines to find an angle in a triangle will only produce one possibility. So let's use the law of cosines. Sort of the moral of the story here is, if you can find an angle using the law of cosines, do it. Don't use the law of sines to find an angle unless you have to. Okay, so with that in mind, we're going to find the angle C. So we'd better use the version of the law of cosines that has the angle C in it. That's c squared equals a squared plus b squared minus 2ab cosine c. All right, now we can put everything in that we already know. 12 squared equals 6.885 squared plus b is 10 minus 2 times a. A is 6.885 times b is 10 times cosine of c. All right, so 144 equals 6.885 squared, that's this down here, 47.4, plus this 10 is missing a squared, that's 100, minus 2 times 6.885 times, let's make this 2 a 20 because of the multiplication by 10, times 6.885 times cosine c. Now we can take this stuff, move it over there. We're going to get negative 3.4 equals minus 20 times 6.885 times cosine of c. And then for c, for cosine of c, when I divide to get cosine of c, I get, let's see, negative 3.4 divided by negative 20 and also divided by 6.885 gives me about 0.02469 and change. And then we can use inverse cosine to find the angle C. So I get 88.59 degrees. Okay, and that gives us the angle C. The only thing left to find is the angle B, and we can do that just with some subtraction, right? Once you know two angles in a triangle, you can find the third. So B is 180 minus A, which we know is 35 degrees, minus C, which we now know is 88.59 degrees. And that's 56.41 degrees. All right, so that's it for this side-side angle triangle. Again, one of the lessons we learned here is if you're trying to find an angle and you have the option of using the law of cosines, use the law of cosines. Okay, now let's try this one. Here we have a side-side-side situation. We know all of the sides and none of the angles. So we're going to have to use two versions of the law of cosines, one to get one for each of two angles. You can find A and B, or find A and C, or find B and C, and then just use some subtraction from 180 to find the remaining angle. It doesn't really matter which you do, so I guess let's start with this version of the law of cosines. So A squared equals B squared plus C squared minus 2BC cosine A. So this is A squared is 25, B squared is 36, C squared is 9. Let's see, B times C is 18 times 2 is 36, cosine A. Okay, 36 plus 9 is 45, so let's subtract that to the other side. So minus 20 equals negative 36 cosine A. So cosine A is, the minus signs cancel. Cosine A is 20 over 36. And we can use inverse cosine now to get our angle A. So A is inverse cosine of 20 over 36. So inverse cosine of 20 over 36. I get 56.25 degrees. All right, so that's A. Now let's find B, I guess, might as well. So this version of the law of cosines says B squared equals A squared plus C squared minus 2 AC times cosine of B. Right? B squared is 36. A squared is 25. C squared is 9. Minus, let's see, A times C is 15. Times 2 is 30. Cosine B. All right, so 25 plus 9 is 34, and subtract. So that's 2 equals negative 30 times cosine of B. So cosine of B is negative 2 over 30, or 1 over 15. And so B is inverse cosine of negative 1 over 15. Don't forget that minus sign, because if you accidentally forget this minus sign and make this thing inside positive, you'll get an angle that's in the wrong quadrant, which you definitely don't want. So inverse cosine of negative 1 over 15, I get 93.82 degrees. Right, so now we know A right here and B right here. The only thing left that we didn't know is C, so now we can just subtract from 180. So C is 180 minus 56.25 minus 93.82. So 180 minus 56.25 minus 93.82. That gives us C is 29.93 degrees. All right, so that does it for our side example.